Now, we shall solve this problem, which is that from the fixed point A on the circumference of the circle of radius c, whose radius is c, the perpendicular AY is let fall on the tangent at P, where P is the point on the circle, and we have to show that the maximum area of the triangle APY is 3 over 8 c square root over of 3 square units. We have to show this. This is the problem, which is that from the fixed point A on the circumference of a circle. A is the point on the circumference of the circle, whose radius is c, small c. The perpendicular AY is let fall on the tangent at P. P is the point on the tangent, that is point of contact. We have to show that the maximum area of the triangle APY is 3 over 8 c square root 3 square units. Now, let us begin. Here we have drawn the circle. This is the circle whose A is the point, fixed point on this circle. A is the fixed point on this circle, and the tangent is drawn at the point P, which is on the circle, same circle. And here we considered the circle's equation is x square plus y square equal to c square, that its center is at 0 0, that is origin. We can consider the origin of the circle as 0 0, and equation of the circle is x square plus y square equal to c square. And also we can consider the coordinate of point of contact of the tangent with the circle as c cos theta, c sin theta. We have taken the point of contact as c cos theta, c sin theta, and Py the tangent, Px the tangent, and Ay is the perpendicular to the tangent. Now, we have also drawn the radius passing through the point of contact, which is MP. MP is also perpendicular to the tangent, because any radius passing through the point of contact is perpendicular to the tangent at this point. So, MP is perpendicular to Px, that is MP perpendicular to Px, and Ay also perpendicular to Px. Ay is perpendicular to Px. Now, equation of the tangent at P is y minus y1, that is c cos theta, y minus y1 y minus c sin theta equal to dy dx at c cos theta, c sin theta into x minus x1, that is c cos theta. This is the general equation of tangent to any curve. This is the equation. Here we can also calculate the dy dx from this curve, that is x square plus y square equal to c square. We can differentiate both sides with respect to x, and we get 2x plus 2y dy dx equal to 0, that is dy dx equal to minus x over y, and also at the point c cos theta, c sin theta equal to c cos theta, c sin theta equal to minus c cos theta c sin theta, which is equal to minus cot theta. This is the gradient of the tangent, and so y minus sin c sin theta equal to minus cos theta over sin theta dy dx at c cos theta c sin theta is minus cos theta over sin theta and into x minus c cos theta. So, y sin theta minus c sin square theta equal to minus x cos theta plus c cos square theta. So, x cos theta plus y sin theta equal to c sin square theta plus cos square theta means c also c. This is the equation of tangent, that is equation of tangent px. This is the equation of tangent px. We can find out the equation of the perpendicular to this tangent. So, equation of the perpendicular ay to this tangent is this equation of this perpendicular is equation is x sin theta minus y cos theta equal to k, where k is the constant, k is a constant, k is a constant. So, this is the primary equation of the perpendicular to the tangent. We have to find out the value of k. Now, mn is all mn perpendicular to ay is drawn. So, value of mn equal to the value of mn means the perpendicular distance of this perpendicular drawn to the tangent, that is ay. Mn is the perpendicular distance of this perpendicular to this tangent, that is mn equal to equation of perpendicular we have already got x sin theta minus y cos theta equal to k. So, perpendicular distance is m is center, from the center perpendicular distance is 0 into sin theta minus 0 into cos theta minus k over root over of sin square theta plus cos square theta, also modulus, that is absolute value, which is k over root sin square theta plus cos square theta is 1, that is k. This is the value of mn equal to k. So, now MP perpendicular to Px AY perpendicular to Px, that is ny perpendicular to px and mn perpendicular to ay, mn perpendicular to ay is drawn. So, this quadrilateral, that is MP yn is a rectangle. MPYN is a rectangle because MP perpendicular to PY, NY perpendicular, MP perpendicular to PX, NY perpendicular to PX, MN perpendicular to AY. So, these three angles are 90 degree. Each of these three angles is 90 degree. So, rest angle is also 90 degree. So, this figure, this quadrilateral is a rectangle. So, MPYN is a rectangle. MPYN is a rectangle. So, we can write Mn equal to, so Mn equal to Py and also MP equal to Yn, MP equal to Yn. MP equal to Yn. So, the area of the triangle APY, area of APY, triangle AP, area of triangle APY, area of triangle APY is half into Py into Ay, Py into Ay. So, half Py equal to Mn into Ay, that is half Mn into Ay, Ay equal to An plus Ny, An plus Ny. From this figure, Ay equal to An plus Ny, and also half Mn into An plus Ny, Ny equal to MP, that is MP, equal to half Mn into An. We can draw Am we can draw Am. After drawing Am, we can we have got a triangle which is a right angle triangle. This triangle is right angle triangle, that is AMN is a right angle triangle because Mn perpendicular to Ay. So, we can also get An equal to square root of Am square minus Mn square plus Mp, because Amn is a right angle triangle because Mn perpendicular to Ay. So, Amn is a right angle triangle, and also from the Pythagoras formula, Pythagoras theorem for right angle triangle, we can write An square equal to Am square minus Mn square. am square minus mn square. So, area S equal to this, that is S equal to half mn. Mn is the perpendicular distance, which is k, which has been got as k, that is mn is already got as k, that is half into k into root over of am square. Am is c, radius is c, radius is c, radius is c. So, am square is c square minus mn square. Mn square is mn is k, that is k square, plus mp. mp is c. This is, that is area S equal to this. S is the area of the triangle APY. So, area S equal to this we have got. For we have to maximize this area. We can maximize this area using the condition of maximization or minimization, using the condition. The condition is the first derivative of this quantity, that is first derivative of S is 0 at maxima minima. At maxima minima, or minima, derivative, that is ds dk, k is variable here, ds dk equal to 0, which implies half root over of c square minus k square plus c plus half k minus 2k over 2 root over of c square minus k square plus 0 equal to 0. This is the differentiation with respect to k of S, that is ds dk equal to 0. Differentiation of S with respect to k equal to 0 at maxima minima, and differentiation is also this, and this is equal to 0. So, root over of c square minus k square plus c minus k minus k square over c square minus k square equal to 0. Now, c square minus k square plus c into root over of c square minus k square equal to 0. So, c square minus 2k square equal to minus c root over of c square minus k square. This is equal to this, and we can take square of the both sides. After squaring both sides, we can take square of both sides. after squaring we get c square minus 2 square 2k square whole square equal to c square this, and also c4 minus 2c square k square plus 4k4 equal to c4 minus c square k square. c4 cancelled out, so c square minus this is 4c square k square whole square, this whole square is a square minus 2a, that is c4 minus 4c square k square plus 4k4 equal to c4 minus c square k square. So, 4k4 equal to 3c square k square. Also 4k square equal to 3c square, because k not equal to 0. So, k square equal to, that is k equal to plus minus root 3 over 2 c. This is the value of k. Also we have the area of the triangle APY S, area S equal to area S equal to half k into root over of c square minus k square plus c. This is the area of the triangle APY. This is the area of the triangle APY, which is considered as S. S equal to half k root over of c square minus k square plus c. And we have to be confirmed about the maximum value of this of the area. For confirmation of maxima, that is maximum value of the area, for confirmation of maxima, for confirmation of maxima, we have to take second order differentiation of the area with respect to k, that is for confirmation of maxima d2 s dk2 must be less than 0, because for maximum minima, for maximum value of the quantity, the second order derivative of the quantity with respect to the variable is always less than 0 for maxima. So, this is the condition for of the maximum value, that is confirmation of this is the condition for confirmation of maximum value of any quantity, and that its second order derivative must be less than 0. We have to show that the second order derivative of s with respect to k is less than 0 at the value at k equal to plus minus root over of 3 over 2 c, that is. So, second order derivative ds dk was half plus c minus k square over c square minus k square. This is also here half is included. This was the first order derivative of s with respect to k. So, we take the second order derivative of s with respect to k. second order derivative d2s dk2 equal to half into minus 2k 2 into c square minus k square minus half 2k over c square minus k square minus half k square into minus 2k into minus 2 c square minus k square over 3 to the power 3 over 2. This is so. This is entirely negative for d2s dk2 at the value k equal to, if we take value of k as root 3 over 2 into c, at this value of k d2s dk2 is negative, that is less than 0 at the value k equal to, at the value of k as root 3 by 2 over root 3 over 2 into c, at the value of k equal to root 3 over 2 into c, d2s dk2, that is second order derivative of the area with respect to k, is less than 0, because this is negative, and also for positive values of k this quantity is negative. So, we are confirmed about the maximum value of S at the value of k equal to root 3 over 2 into c. So, we are confirmed of the maximum value of the area of triangle APY at k equal to root 3 over 2 into c. At k equal to root 3 over 2 into c, the area of the triangle APY is maximum. So, maximum value of the area of the triangle APY. So, maximum value of this of the area, maximum value of the area equal to half into k root over of c square minus k square plus c at k equal to root 3 over 2 into c. Equal to, if we put the value of k equal to root 3 over 2 into c, we get half into root 3 over 2 c into root over of 3 c square minus 3 over 4 c square plus c equal to root 3 over 4 c into 1 4 c square, that is half c half c plus c equal to root 3 over 4 c into 3 over 2 c, which is equal to root 3 over 8 c square root 3. This is the value of the area of the triangle APY, maximum area of this triangle. This is the maximum area, this is the maximum area of the triangle APY. So, maximum area of the triangle APY is 3 over 8 c square root 3 square units. Thus, we have found out the maximum value of the area of the triangle APY, which is formed by the perpendicular AY, tangent PX and the line AP. This is the triangle. We have to maximize the area of this triangle, and we have also maximized the area of this triangle, and maximum value of the area of this triangle is 3 over 8 c square root 3.